Welcome to Linux Hardening Mastery. Lesson 1. SSH is the front door to your server, and right now it's wide open. Port 22, password auth on, root login allowed, thousands of brute force attempts hitting it daily. By the end of this lesson, that door is sealed. Key-only auth, alternate port, IP allow list, root login killed, and a match block for your Bastion host. We're shipping real hardening changes today. Don't take my word for it, here's the proof. Fresh Hetzner droplet, 24 hours, no DNS, no advertising. 8,247 login attempts, 1,800 unique IPs across 47 countries. 94% tried root as the username. This isn't targeted, it's the background radiation of the internet. Botnets sweeping IPv4, hammering port 22 with dictionaries of root, admin, Ubuntu, Oracle, Postgres, Git. If your server is online, this traffic is hitting you right now. So let's start sealing that door. The default SSHDR config is 100+ lines of comments and defaults. Ignore most of it. Drop your changes into a separate file at etc. shhssd.config.d99 hardening. Conf, it's cleaner, and it survives package upgrades that would otherwise overwrite your work. These are the 8 directives that actually matter. Move off port 22, kill root login, kill password auth entirely, require keys, allow list specific users, cap auth tries at 3, tighten the grace window to 30 seconds, and clean up dead sessions. And one rule, non-negotiable, run SSCharms, DT before you reload. Bad config plus reload equals locked out. Now the single biggest lock on that door, kill passwords entirely. Generate an ed25519 key pair on your laptop, never on the server, and protect it with a real passphrase. Push the public key up with SSH copy ID, then, and this is critical, open a second terminal and confirm key auth actually works before you flip password authentication to no. Test, then disable. Skip that test and you're locked out. And ed25519 over RSA every time. Smaller, faster, modern elliptic curve crypto. 2 more locks, both cheap. Move SSHG off port 22 to something high like 22 and 22. It doesn't strengthen the crypto one bit, but it sheds about 95% of the automated scan noise overnight. Open the new port in UFW first, keep a temporary allow on 22 from your own IP, reload, and verify you can log in on 22.222 before you tear down the old rule. Then layer on the allow list. Restrict the new port to your Office or VPN range, either at the firewall or with a match address block in SSG config. Together, brute force traffic goes from thousands a day to 0. Next lock, kill direct root login entirely. When everyone SSHs in as root, your auth log just says root logged in from somewhere. You have no idea which admin ran what, and if creds leak, every action is unattributable. Force named users instead, then let them escalate with sudo. Drop permit root login no and allow users into your hardening conf, and now every command traces back to a person. Audit trail, smaller blast radius, compliance happy, all from 2 lines. But strict global rules break the moment you have edge cases. A CI/CD bot that should only run 1 deploy script, a backup user that's allowed in from exactly 1 IP and nothing else. An admin group that genuinely needs agent forwarding for jump host workflows. That's what match blocks are for. Per user, per IP, per group rules living inside the same SSD config. Lock the Cybot to a force command with no TTY. Pin the backup user to 10.0.5.42 and croot them into SFTP only. Grant admins what they need and nothing leaks to anyone else. Even with keys and an alt port, the probes never stop, and every failed attempt lands in auth.log. That's your hook. Point failban at it with a simple SSSG jail, 3 fails in 10 minutes, 24-hour ban. Or skip the jail config entirely and let CrowdSec do it. Install the SSHD collection, reload, and you're pulling community block lists with thousands of IPs banned daily. Pick one, not both. Fail to ban for a single box, CrowdSec when you're running a fleet. For high assurance hosts, finance, healthcare, anything regulated, a key alone is still just something you have. Stack a second factor on top. TOTP is the easy win. Install libpam Google Authenticator, run the setup to scan a QR, then wire it into PAM and set authentication methods to public key plus keyboard interactive. Now login needs the key and a 6-digit code. For execs and privileged admins, go further. FIDO2 with a YubiKey. SH keygen with EDI25519SK, resident and verify required, and every login demands a physical touch. Phishing proof. Skip all this on lab boxes, it's overkill. Before you reload SSJ on a remote box, burn these 5 into memory. 1. Never disable password auth without confirming your key works in a second terminal first. 2. Allow users will lock you out the moment you forget to list yourself. 3. Open the new port in the firewall before changing it in SSH config. 4. A bare match at the top of your config silently rewrites the rules for everyone. And 5. Wrong permissions on .sh or authorized keys, and SSH rejects the key without mercy. Every operator has been bitten by at least one of these. Don't be the next. Step back and look at what you've built. 6 layers stacked. Config hygiene, key-only auth, an alternate port behind an IP allow list, root login killed, match blocks for the edge cases, and an auto banner watching the logs. Your front door is locked against roughly 99% of what the internet throws at SSH every day. But a determined attacker who lands a key still has one move left: escalation. That's where Lesson 02 picks up. Sudo, nopass, wd scope, and command logging. The next layer in. Lesson 01 complete. Key-only auth, alt port behind an allow list, root SSH dead, match blocks ready. The front door is locked. Next up, the privilege ladder. We'll carve up, charges etc. sudo as.d with clean drop-ins, tighten nopass wd to exact commands, turn on command logging, and replay sessions with sudo replay. Run next lesson, start, and I'll see you in Lesson 02.